Okay, so now for video 4, we're going to be talking about the product and quotient rules. And in this video, I'm going to talk about both rules and I'm going to show how both rules are derived. So first we have the product rule. The product rule says that if h of x equals f of x times g of x, then h prime of x, or the derivative of h of x, equals f prime of x times g of x plus f of x times g prime of x. So let's look at this first example. If we have y equals x to the fourth plus 2x times 6x to the fifth minus x cubed, then we can see that this, okay, we can say that this, or we can make this f of x, we can make this g of x. So now, if we follow this rule here, y prime would equal equal the derivative of f of x, or f prime of x. So that would be 4x cubed plus 2, and then multiplied by g of x, just regular g of x, so 6x to the fifth minus x cubed, plus f of x, x to the fourth plus 2x, times g prime of x, so 30 x to the fourth minus 2x squared, or 3x squared, sorry. Oops. So yeah, that would be the how you would apply the product rule in this case. So now moving on to the quotient rule. If h of x equals f of x over g of x, then h prime of x, or the derivative of h of x, equals f prime of x times g of x minus f of x times g prime of x, all over g of x squared. So as you can see, the top is very similar to the product rule, except here you have a negative sign. So let's move on to an example. Here we have y equals x to the fourth plus 2x, all over 6x to the fifth plus x cubed. So if we want to find the derivative of y, then we can make this numerator f of x, and this denominator g of x. And if you remember, our formula is f prime of x times g of x minus f of x times g prime of x, all over g of x squared. So this would equal the derivative of this, so 4x cubed plus 2 times g of x, 6x to the fifth plus x cubed, minus f of x, so x to the fourth plus 2x, times g prime of x, so 30 x to the fourth plus 3x squared. Oof. Yeah. All over g of x squared, so 6x to the fifth plus x to the third squared. So yeah, that is how you use the product and quotient rules. And now I'm going to show you how we derive the product rule. So here's a proof. Let's say we have p of x. If p of x equals f of x times g of x, then p of x this should be p prime. P prime of x equals f prime of x times g of x plus f of x times g prime of x. That is your basic product rule. So now, if we say, let's look at each part individually. For f of x, we have the derivative of f of x is f of x plus h minus f of x all over h as the limit h approaches 0. And then we have g of x. The derivative of that is right here. Same thing, except we use g's instead of f's. And then we have f prime, or p prime of x, which is also the same thing, but with a p. And so we're trying to prove that p prime of x equals f prime of x times g, okay, actually scratch that. Okay, well I can't erase it, actually. So, let's just scratch this out. We know that p prime of x is the same thing as f prime of x times g of x plus f of x times g prime of x. And from the previous slide, we had different values for each one of, for f of x, f prime of x, and g prime of x. So now we can plug in those values. So f prime of x is the same thing as f of x plus h minus f of x all over h. But since we're actually going to combine these, this is kind of complicated, but hopefully it makes sense. And then multiplied by g of x, which is just so now I'm starting over. Okay, so let's prove that p prime of x equals f prime of x times g of x plus f of x times g prime of x. So we know that p prime of x equals this right here. And so for p of x plus h, we can substitute that with f of x and g of x, or f of x plus h and g of x plus h. So now we have the limit as h approaches 0 of f of x plus h times g of x plus h. And then minus p of x, which is f of x times g of x. And then all over h. And so if we continue this, I can plug in, I can plug in these values right here. Negative f of x times g of x plus h plus f of x times g of x plus h, because they cancel each other out. So I plugged those two blue terms into my equation. And now I can separate this equation into two separate fractions. So let me see if I can copy this over to a different slide. Okay, so I rewrote the same equation, and I made my the thickness of my pen a little bit thinner so that I have room to write everything. So as I said, I can split this big fraction into two separate fractions to prove that the product rule exists. And so I can divide it kind of like right down here. And so I end up with f of x plus h times g of x plus h, or the limit as h approaches 0. Sorry, I don't want to forget that. Oh, that's messy. Oh well. You should understand what I mean. Yep, so just rewriting this as two fractions. Oh, oops. Limit as h approaches 0. Okay, so if I have that, I can see here that I can factor out g of h plus x over here, and I can factor out f of x over here. So I end up with the limit as h approaches 0 of f of x plus h minus f of x over h times g of x plus h plus f of x, and this f of x can be brought out because it's not affected by the h, times g of h plus x plus h minus g of x all over h. And as you can see, or maybe not, but as I'm pointing out, here we have f prime of x. Here we have g of x. Here is f of x. And then here is g prime of x. So we end up with p prime of x, the derivative of p equals f prime of x times g of x plus f of x times g prime of x. Yay! Yay! So yeah, there is your proof. And now on to the proof of the quotient rule. Okay, so here I have the quotient rule. Q of x equals f of x over g of x. Then q prime of x equals f prime of x times g of x minus f of x times g prime of x all over g of x squared. And so, if I look here, I can rewrite this equation. Hold on. Okay, yes. So if g prime of q prime of x, equals the limit as h approaches 0 of q times x plus h minus q of x all over h, then that's the same thing as the limit as h approaches 0 of f of x plus h over g of x plus h minus f of x over g of x all over h. So this equals the limit as h approaches 0. I'm going to make the I'm going to take out the 1 over h, basically. So 1 over h times f of x plus h. And I'm going to make the numerator have a common denominator, if that makes sense. So I'm going to multiply this first fraction by g of x and multiply the first fraction by g of x over g of x, and the second by g of x plus h over g of x plus h. So multiplying this by g of x, multiplying this by g of x plus h, and then my new denominator becomes g of x plus h times g of x. So I'm going to continue, and like last time, I'm going to add in additional parts that cancel each other out. So here I'm going to add in a negative f of x times g of x. Here I'm going to add in a then I have that same part that I had before. Then I'm going to add in a positive f of x times g of x. And then this is all over g of x plus h times g of x still. Okay. And now I can divide this again into 2 separate fractions, and so I'll end up with this. So f of x plus h times g of x minus f of x times g of x. Oops, getting ahead of myself. All over g of x plus h g of x minus the limit is h approaches 0, 1 over h. Oh man, running out of room. This looks pretty nasty, but it's a proof, so it'll get better. So now I have all of this. And if you look closely, I can also write this as the limit of h approaches 0, 1 over... Okay, actually, here... The limit as h approaches 0 of f of x plus h times g of x Oh, sorry. Okay. I skipped a step, kind of. Or I forgot to do a step. What I'm going to do now is I'm going to factor out this g of x here. And then on this side, I'm going to factor out f of x. So I end up with this f of x plus h minus f of x all over okay, and then I'm going to make this, I'm actually going to combine these two parts, so instead of having 1 over h here, I'm going to make this an h here. Then I'm going to multiply that by 1 over g of x plus h over g of x. And then all of this times g of x. And I'm going to do the same thing on the other side, except I'm kind of out of space. So basically what I would do is I would take out the f of x and move it to the front here outside of the limit because it's not affected by the h. And so I end up with these two parts. I'm just going to rewrite. Limit as h approaches 0, 1 over g times x plus h times g of x times f of x plus h times f of x, or sorry, minus f of x all over h, all of this multiplied by g of x. Okay, so something happened to my recording and I don't know what happened, but basically I rewrote out this equation up here in green, and I found out that I kind of like just dissected each part, and I found that this part right here is g of x squared, or 1 over g of x squared. This part is f prime of x, this part is g of x, and then this is one part, and that's subtracting f of x times 1 over g of x squared times g prime of x. And so I rewrote all of this into one big fraction because they have the same denominators of g of x squared. And so I end up with my quotient rule right here. And that is the proof of the quotient rule. So hopefully by watching this you got a general idea of how the product and quotient rule work and how they were derived. Yay!